Okay, so the purpose of this video will be to talk about curvature. So let's start with the definition. The curvature KT is the magnitude of the rate of change of the slope of the tangent with respect to the rate of change in the arc length over a short period of time. So let's imagine we have some curve. And this section here, the arc length S of t, we have a tangent, which is changing as we move along the curve. So the curvature will be the magnitude of the rate of change of the tangent with respect to the rate of change in the arc length over some short period of time. That is to say, K of t is equal to the magnitude of dt ds, the rate of change in the tangent, over the rate of change in the arc length. And that should be dt dt times dt ds, where by dt ds we mean just 1 over ds dt. And of course we know that ds dt is r prime of t. So we have k of t is equal to the magnitude of t prime of t over r prime of t. Now we want to solve a problem. The given problem is finding the curvature when r of t is 6 cosine pi t I cap plus sine of pi t j cap. So r of t is 6 cosine of pi t I cap plus sine of pi t j cap. We need to find the derivative, so we'll say r prime of t is going to be minus 6 pi times sine of pi t I cap plus pi times cosine of pi t j cap. Then t of t we know is r prime of t divided by its magnitude. So that's going to be the derivative that we just found, negative 6 pi sine of pi t I cap plus pi cosine of pi t j cap divided by its magnitude, which will be square root of minus 6 pi sine of pi t, everything squared, plus pi cosine of pi t, everything squared, square root of all of that. And we'll simplify it as much as we can. So on top, still negative 6 pi sine of pi t I cap plus pi cosine of pi t j cap. And on the bottom, we're going to get pi squared in both places. So let's go ahead and pull pi out of our square root and just say we have 36 sine squared of pi t plus cosine squared of pi t, then that pi will cancel with the top. So finally I'm going to say this is minus 6 sine of pi t I cap plus cosine pi t j cap divided by the square root of 36 sine squared pi t plus cosine squared pi t. All right, so that gives us our t, but we also need t prime of t. So we're going to take the derivative of what we just found, which means, of course, we'll need to use the quotient rule. So we will take the derivative of the top. That's going to be minus 6 pi cosine of pi t I cap minus pi sine of pi t j cap. And that, of course, gets multiplied by the bottom. So multiplied by 36 sine squared of pi t plus cosine squared of pi t, square root of all of that. Then we need to subtract. So I'm going to start a big square bracket here. From this, we're going to subtract minus 6 sine of pi t I cap plus cosine of pi t j cap. And we need to multiply by the derivative of the bottom. So we know we have the derivative of this form. It goes on the bottom of a fraction 2 times what's under the square root. And then we also need to multiply by the derivative of the inside. So we're multiplying by 72 pi sine of pi t cosine of pi t minus 2 pi sine of pi t cosine of pi t. Now all of that needs to be divided by the square of the bottom. So that's going to just be our 36 sine squared of pi t plus cosine squared of pi t. Okay, let's see what we can simplify here. So first of all, I want to get rid of this fraction. So let me multiply by 2 square root of 36 sine squared of pi t plus cosine squared of pi t everywhere. So this is going to be equal to, when I multiply by the square root, this term, the square root term here, is just going to be 36 sine squared of pi t plus cosine squared of pi t. And then this other term I'm going to multiply by 2. So that's going to be minus 12 pi cosine of pi t I cap minus 2 pi sine of pi t j cap. Then here where I subtracted, my bottom cancels. So I have just minus sine of pi t I cap plus cosine of pi t j cap, and still multiplied here by, this is 72 pi sine of pi t cosine of pi t minus 2 pi sine of pi t cosine of pi t, so I can just make that 70 pi sine of pi t cosine of pi t. And this whole thing is still divided. I'm also multiplying that 2 square root of 36 sine squared pi t plus cosine squared pi t on the bottom. So this becomes 2 times, and now this thing will be to the power 3 over 2. So 36 sine squared of pi t plus cosine squared of pi t, that is all now to the power 3 over 2. Okay, and what else can we simplify? So let's go ahead and multiply these out on top. So here I'm going to get minus 432 pi sine squared of pi t cosine of pi t I cap. And I'll also have minus 12 pi cosine cubed pi t I cap. Then I should get minus 72 pi sine cubed of pi t j cap minus 2 pi cosine squared of pi t sine of pi t j cap. And then minus, let's see, here I get minus 430 pi sine cubed of pi t, I'm sorry, that's sine squared, we can just get rid of that, sine squared of pi t times cosine of pi t I cap. And then plus cosine squared 70 cosine squared of pi t sine of pi t j cap. We're still dividing by 2 times 36 sine squared of pi t plus cosine squared of pi t to the power 3 over 2. So let me just take a look here and make sure before we move on that that looks correct. So minus 432 minus 12 minus 72 minus 2 pi let's see, 70 times 6, I think that should give me 420. And then I just forgot a pi here. So let's see if we can squeeze it in. All right, and then we'll keep simplifying. Okay, so I have, it looks like 432 pi sine squared cosine of pi t I cap plus 420 of the same. So combining like terms, I get to say this is just minus 12 pi cosine of pi t times sine squared of pi t I cap and minus 12 pi cosine cubed of pi t I cap minus 72 pi sine cubed of pi t j cap. And then here this 70 and this 2 are like terms, so that's going to be minus 72 pi sine of pi t times cosine squared of pi t j cap. And everything's still divided by 2 times 36 sine squared of pi t plus cosine squared of pi t, everything to the power 3 over 2. Okay, I think we're getting close to something that doesn't look so bad. So now it looks like I can factor minus 12 pi cosine of pi t times sine squared of pi t cosine squared of pi t. I'm sorry, sine squared of pi t plus cosine squared of pi t, and that's times I cap. And similarly, I can factor here minus 72 pi sine of pi t, again. And that's also going to be sine squared of pi t plus cosine squared of pi t. That's my j cap term. And everything divided by the same bottom. And that's nice, of course, because I don't have to worry about those anymore. I just get to say negative 12 pi cosine of pi t I cap minus 72 pi sine of pi t j cap. And I'm going to go ahead and factor out 2, cancel it with the bottom. So let's say minus 6 pi cosine of pi t I cap minus 36 pi sine of pi t j cap. Canceled my 2. So now I just have 36 sine squared of pi t plus cosine squared of pi t, everything to the power 3 halves. And that looks quite a bit better than where we started. So now we know our t prime and we know our r prime. So we're going to use those. R prime here. This is our t prime. Okay, so we're coming down the home stretch. Now we need the magnitude of t prime. So magnitude of t prime and that's going to give us the square root of Alright, so we need the magnitude of t prime of t divided by the magnitude of r prime of t. So I'm going to look at my t prime of t term. I know that the bottom here is just a constant, so let me write that back down. That's 36 sine squared of pi t plus cosine squared of pi t, everything to the power 3 over 2. And for the magnitude, I'm going to do minus 6 pi cosine of pi t, everything squared, plus minus 36 pi sine of pi t, everything squared. That's my magnitude of t prime. The magnitude of r prime, we already used a little bit earlier in the problem. Let's see, way back up here, and it was just this pi times the square root of 36 sine squared pi t, cosine squared of pi t that you see here. So that was pi times square root of 36 sine squared of pi t plus cosine squared of pi t. Then t prime of t over r prime of t's magnitude, which of course is just the magnitude of t prime of t over the magnitude of r prime of t. Well, that's going to be the square root of 36 pi squared cosine squared of pi t plus 36 squared is 1296 pi squared sine squared of pi t and of course we're over 36 sine squared of pi t plus cosine squared of pi t, everything to the power 3 over 2. But when we multiply in, or rather when we divide by the magnitude of r prime, we're going to have one more copy of the square root of 36 sine squared pi t plus cosine squared pi t. So I can simplify that. I can pull out 6 pi from the square root on top, which gets rid of 36 pi squared. And on top I have then cosine squared of pi t plus 36 sine squared of pi t and on the bottom, combining like terms, 36 sine squared of pi t plus cosine squared of pi t. I have to the power 3 halves plus to the power 1 half, so that's to the power 2. And you'll see I get a nice cancellation here. I get 6 on top, because pi cancels with pi, and the square root can cancel with the bottom, making it again to the power 3 halves. So we finally get to say that for this problem, the curvature KT is 6 over 36 sine squared of pi t plus cosine squared of pi t whole to the power 3 over 2. And that answers the question.